Okay, in this tutorial, I'm going to go through a worked example for the chi-square statistical test and show you the typical types of questions that you like to encounter in relation to this particular statistical test and what you would be writing if you did encounter them. What I suggest you might wish to do is actually pause the video at various points, try answering it yourself, and then compare it to what I say. So before we explore question number one, which is to state the null hypothesis, let's just climb into the question and consider what the data is that we've been given in this table and what the actual scenario is. So we are told that a survey has been carried out at Brockhall. And Brockhall is the Lake District Visitor Centre, which happens to be in Windermere. Now, we don't need to know anything about Windermere, but we're probably all familiar with what a visitor centre is. And we also know what a survey is. And the survey has been carried out to establish the distance people have travelled to visit the Lake District National Park and how long they stayed with each visit. So we have a visitor being surveyed and they are asked how far have they travelled and then how long are they going to stay in the national park. Now, in this survey, the results have been grouped into two groups. Group A, and we can see the results down here, are the respondents who said that they lived within 30 kilometres. So their answer was that they were within the 30-kilometre radius of the national park. Group B were the respondents who said that they lived beyond 30 kilometres. And we can see their results down here. Furthermore, the data has then been divided into people that responded that they were going to stay up to 4 hours in the national park before leaving. The second group were between 4 hours and 24 hours or 1 day. And the third group were those staying longer than 24 hours or more than 1 day. Now, in this table, we, as would possibly expect, just doing a kind of basic bit of analysis, can see that the people that live nearer in Group A, those are those that stay within 30 kilometres, far more of them are only staying up to 4 hours. And that might very well be to do with the fact they live quite close to the national park, and therefore they are just visiting for a short visit. Likewise, those that are coming from a further distance to travel to get there are much more likely to stay more than 24 hours. Because they're making a much bigger distance journey to get there. And that's probably why this survey is being conducted. Does the distance you live influence how long you stay? Now, why do a chi-square test? Well, we have gathered in frequency the number of people that have responded. So 32 people who lived within 30 kilometers said they were going to only stay up to 4 hours. So this 4 hours is a category, and then they've been subcategorized as either within 30 kilometers or more than 30 kilometers. And because we have frequencies, we would be using chi-square because we've gathered the number of frequencies in each of our categories. Furthermore, we have 5 or more values in each of our groups, in each of our categories, and we can therefore do the chi-square test. So that is why chi-square is being used. And as with this test, as with many other tests, we are always asked to state a null hypothesis. So you might go and try to decide what that null hypothesis might be. If you've written it out, what you would have or should have written is that there is no statistically significant difference, and that word difference is key here, between the distance people live from the national park and the length of time they choose to stay. So what we're saying when we state the null hypothesis is that there's no difference between group A and B in terms of the length of time that they are going to stay. Now, if we were to go ahead and do the chi-square test, we would get a result, and I'll show you what that result is now. That result is 42.48. Now, with chi-square, that result means nothing in of itself. You cannot say anything about that number, unlike some other statistical tests where the number itself you can start to infer something. What you now need to do is calculate the degrees of freedom. Now, the degrees of freedom are the number of rows minus 1 times the number of columns minus 1, or 2 minus 1 times 3 minus 1. I'll just show you where that comes from. So we have 2 rows of data, row A and row B. So that is rows, so it's 2 minus 1. And we have 3 columns of data. There they are, there's the 3, and it's 3 columns minus 1. So 3 minus 1 is 2. So we have 1 times 2. So our degrees of freedom is 2. The next thing we need, once we've worked out the degrees of freedom, and the exam board may give you the degrees of freedom in the exam. You might not be required to calculate that. We now get our table. Now, once again, the exam board may just give you one part of this table, in which case that would be this row here. They may not give you the rest of the table. If they give you the whole table, it'll be worth more marks because they'll be asking you to calculate the degrees of freedom, first of all, before then applying it. If they just give you the result, it'll be worth fewer marks. So now that we know we have 2 degrees of freedom, is our result, and let's just have a look, remind ourselves what it was, 42.48, is that larger than either of these results? Well, it is larger than this. So that is the 0.05 or the 95%. Now, because it's larger than that value, we can automatically reject the null hypothesis and accept the alternate, which there is a statistical relationship between the distance somebody lives from the national park and how long they stay. And as a matter of fact, because we can get above the 9.21, we can go as far as saying it is significant to the 0.01% level. We are 99% sure that there is a difference between the distance people live and the time they spend in the national park. Okay, so let's just have a little look back at the exam question. We have now talked about the result. And is it significant? Yes, it is. And that question itself would probably be worth about 3 marks. The key question comes in this one here. You can see it's a 4-mark question, commenting on the usefulness of this technique. Now, what I'm going to do is I'm going to show you the mark scheme for this question. And what's important is you relate your points to the actual table of data that you're given. So your answer is authentic. We just scroll down and have a little look at what the exam board said. So what makes this a good test? The test is useful in measuring the difference between what has been observed. So that is the actual people that we asked the key questions to and where they lived, how far away they lived, and how long they were going to spend, and what is expected. And expected is just a mathematical calculation. And that's what chi-square is based. Is there a difference between what we ask and what we expect? It's useful when the expected distribution is not known. Okay. Useful when the data can be grouped into classes. Well, we can see in this example that our data has been grouped into 2 groups where based on how far people live, and then subcategorized into groups of how long they're going to spend. And then we've calculated the number of people that responded in each of these categories. So chi-square is definitely suitable on that basis. We can also compare our value to a significance table to determine whether we're just seeing random or actually there is a statistically significant difference. Because if there is a statistically significant difference, which we did actually in the previous part of this question prove, then there must be a reason for that. It's not just random. Okay. So what else can we say? Well, this test needs a minimum of 20 observations. Well, I'm quite happy to say that we have definitely more than 20 observations. We can see that. Also, each category or each cell has to have a frequency of greater than 5. Well, that is appropriate because our data set, the lowest was for Group B, where we only had 11 people staying up to 4 hours, but that is considerably higher than 5. So once again, it's much more likely that our results are accurate and should be trusted. Our data has to be in the form of frequencies. Well, it is, and I've already discussed that. Our data must have precise numerical values. So these numbers, these represent each person that gave an answer, which is a precise numerical value. It's rather than a derived value or a number we've assigned on the basis of something. A piece of nominal data or ordinal data or ratio data. These are actual people that gave a response in one of these categories, and therefore we can use this data because it's got precise numerical values. And as I've already said, it's organized into categories or groups, which is important. Okay, so for all of those reasons, the chi-square test is a suitable test because it does allow us to determine a mathematical probability of something being, of there being a difference between, in this case, two groups of people and the length of time they're going to spend. It would then allow us to explore why there is a difference in the length of time people spend, which clearly has got something to do with the distance they're traveling. But why does distance traveled influence how long we spend? Which, as geographers, might be something we would explore. And you could certainly make that point. Once we prove that there is a difference, we then want to find out why.